Hello and welcome to the first video that we're going to be making for your instruction. We're going to start with the basics. We're going to be looking at Intro to Science. This is the first of about 4 videos. We'll look at a number of different things in these videos. Today we're mostly going to focus here on units and measurements, which should have another slide for, yes. All right. So units and measurements. Why units and measurement? Well, because it's a little bit unique from math and science. If you were doing math class, you probably did a simple problem and you said something like, hey, I have 8, I divided it by 2, that equals 4. And you're all happy because you're like, yay, I got 4. 4 tells me everything. In science, not so much. In science, we need to know what you were dealing with first in your problem. So was it 8 miles divided by 2 gallons? And that probably got you that you now get 4 miles per gallon in your car. See, the science helps you understand what the numbers represent and what they're talking about. So it wouldn't be until you have a number and a unit that it is a proper measurement in science. Okay, so here we are in our first video, and we're going to be learning about units. Now, your first video is going to be on just really figuring out our SI unit. So video 1 is going to be this in units, but then video 2 is also going to cover conversions. That's where we're changing them. I broke it down into 2 just for fun. Our third video is going to be all about scientific notation, and our fourth video is going to be about scientific method and the variables in experiment. All of this stuff is going to be pertinent in whatever science you're going to be doing. But we're going to start today with SI units. Okay, one of the first things I think a lot of people have trouble with is understanding the difference between a formula and a unit. So I said in this thing we're going to be talking about units, right? Well, the units always follow different numbers and they identify what the number is. A formula is used to say how you're mathematically going to work 2 things together. So let's say a formula that everybody pretty much has to get familiar with is going to be something like the formula for force. So when we calculate force, we say that force is equal to mass multiplied by an acceleration. All right? So we shorten that to just say F equals m times a. So that's our formula. It's how we work those things out. And yes, it's a letter to represent things. It isn't a mathematical equation, but it is completely different from units. Units would be things like if you have, it identifies a number. So 4, and we said newtons. Would be how it is then measured. So after you did the force formula, you might get up with an answer that is 4 newtons. And newtons is a unit of measurement of force that we'll be looking at. Same as if you multiplied things together and you got how fast something was going, and you got like miles per hour, right? So you might have that you drove at 60, and your units are going to be miles per hour. And so those units identify just one number. The formula up here shows you how to mathematically do things. Okay, so in the sciences, they needed a standard unit of measurement. If we have things like feet and then other people have things like a meter, it's just not going to work out very well. So we needed one thing that allowed us to use the same units for everything. They call this the International System of Units, or you'll hear it said SI units. SI units, some people just call it the Standard International Unit. Some people call it your standard units, but SI units is the short term to refer to the units you have to use in science. And yes, it uses the metric system because it's all through power of 10 in multiplication and division. That means moving up or down in your scale is much, much easier. We're going to use things like meters, that will cover a distance, liters, that covers volume, grams, we'll actually probably see kilograms, you'll learn because grams are so tiny, but still grams are the SI unit for mass. And then you are used to seconds probably for time. Amperes, if you're not sure what that is, it's an electrical unit. And we'll be looking at that just a little bit when we get to our electric unit. So on this page we have our SI units. Notice there's two different types of SI units. We have our base units, like these up here, things like meters, kilograms, seconds, amps. Kelvin is actually for temperature. Moles is important if you do chemistry. Candle or a luminosity, basically. It's how you measure how bright a light is. All of those measure one particular thing. It's made of one symbol that you can see right over here. At that same time, we also have derived units. That word derived just means that it's made up of base units. So it still has one name to represent one thing, like hertz for frequency or newtons for force, and we're still going to use one symbol. But it might be helpful to know that that's actually made of multiple different units being put together. So let's take a look at how we get a derived unit by looking at the example we looked at earlier. We started with a force formula, and that force formula we said force is equal to mass times acceleration. Well, if I did mass, my units for mass are going to be kilograms, and I'm multiplying that times acceleration. My acceleration units are going to be meters per second squared. And so if I multiply those two units together, I'm going to get a new unit that would be kilogram times meters divided by seconds squared. But instead of having to write all of that out, we just say that force is really a derived unit that is equal to newtons. So that is what we mean by a derived unit. It's still used to identify one thing, like force. And again, it would always be preceded by a number of some sort. So this could be 2 and 2 over here, and that would end up being 4 newtons, right? So you do things like that, but the newton is a derived unit.